Hello everyone, myself Arpajatide, and in this video, we are going to solve a lead code question from the recent contest 431. The title of the question is Maximum Subarray with Equal Products. So, before starting with the question, we should understand the question, before starting with the coding part, we should understand the question very well. So, what does the question says? The question says you will be given an array. The name of the array will be nums, and what you need to find, the longest subarray that is a product equivalent. So here a name has been given as product equivalent. So what is a product equivalent? Product equivalent is nothing but the product of that part of the array should be equal to the LCM of that part into the HCF. So the first thing is, what is a subarray? Right. A subarray is a continuous portion of the array. Like here you can see, suppose I take this one 3, 4, 5, 1, 2. 4, 5, 1 is a subarray of this whole array. 5, 1, 2 is a subarray. 3, 4, 5 is a subarray. So subarray is basically a continuous portion of the array that like of without changing the order, and the elements should be consecutive ones. Like we can't take 3, 4 and 2 from here. If we make 3, 4 and 2, this will be called as subsequence without changing the order. If we like take any elements from there and put it, it will be called a subsequence, not a sub array. So we get to understand that what is a sub array. The next part will be like you need to here find the longest subarray length that satisfy this condition. So how can we actually approach it? How can we like code it? First of all, let's think the most naive or brute force approach. Suppose this is my array. I'm not showing the elements. Suppose we can have any random elements. But now I wanted to consider each and every sub array of this. How is it possible? So by brute force way, I can take this, I can take this, I can take this, and after taking everything from the first position, I can take this one, this one, this one, this one. The same thing that we used to do is selection sort, right? So like this way, we can have each and every subarray. We can have each and every subarray to us. If we can have each and every subarray, then we need to check two things: the product of the array, the LCM, and the greatest common divisor, that is the GCD. So how can we do that? How can we do that? Suppose I got this subarray. Consider this part only. Okay. From using two for loops, I can get each and every subarray, and the ith and the jth index will represent me how much portion of the subarray I am considering right now. How can I do that? I can have a low and a high. Low and a high indicates that with how much portion I am working right now. That part of the array, low and high, will indicate. Low is the lower bound, high is the upper bound. Okay. So now what we can do, is we can easily find the product of the array. How can we find the product of the array? We will run a for loop from L to H, and we will multiply with each term, right? For like this way, you can easily find the product of the array. But the problem will come when you are trying to find the GCD or the LCM for a portion of the array. How can we find the GCD or a LCM for a portion of the array? Okay, so let's not consider a portion. Suppose, do you remember how you used to calculate the GCD of two numbers? Suppose we have been given two numbers x and y. How we used to calculate that GCD? GCD means greatest common divisor, right? So when we are small, we used to calculate like suppose we have been given two numbers and we need to find GCD of 4 and 6. How we used to do that? We used to do it with the long division method, right? So if how can I make it? So here 6, 4 ones are 4, the remainder is 2, and again we will take this one here, 4, 2, 2s are 4, and the remainder is 0. As soon as the remainder is 0, this is my answer. My answer is 2, right? So how can we be able to code it? How can we be able to find the GCD of these two numbers? We can find GCD of these two numbers by uh, running a for loop from GCD, right? For loop from 0, no, not 0, from 1 to like any one of them, x or y. Let's take max of x, y. We will run a for loop, and my GCD will be whenever I will divide. Here should be a condition: whenever I will divide both x and y, that will be my GCD. And after traversing the whole array, you will find out that you will get the largest divisor here. But it is an iterative method and it would take a lot of time. So what can we do is we can there is a recursive method to do this, and in a pretty less time consuming, pretty less time complexity. So how can we do this thing? Is it is same as the long division method that I have shown you just now. So what we can do, finding the GCD, right? So here is the thing. We can have like GCD of x modulo y, and if x is equals to 0, return y. So we are now focused on the part how to find GCD of two numbers. How can we find GCD of two numbers? Is suppose we have taken two numbers, we will make a function here, GCD. We take two numbers x and y, and this will be my scope. I'll be using recursion. So for using recursion, we should have high level thinking. What is high level thinking is we should think in terms of three things: the base case, the recursive work, and the self work. Recursive work means the work that you want recursion to do itself. The self work, that is the thing that you need to do in each and every step. And the base case is the terminating case, as you know. or the halting case, I think it's called. Okay, so what, suppose here is 4 and here is 6. Suppose our x is 4 and y is 6. 4 ones are 4, 4 twos are 6. Oh, sorry, 4 ones are 4. We are getting remainder 2, and here will be 4. So see, for the next time, for the next step, my x transfers from 4 to 2. And how we are getting to? We are getting to by performing this function 6 modulo 4. 6 modulo 4 is giving us 2 because modulo gives us the remainder, right? So 6 modulo 4 is giving us 2 here. So what can you do that and it will be done again and again. So what can you do? 6 modulo 4 will give you this 2, and this 4 will be my y. This is my y for the first step, this is my x for the first step, this is my x for the next step, this is my y for the next step. And 2 2s are 4, 0. As soon as this is my x for the third step and my y is like nothing, like as 0, return. So you can see one thing, when this long division method will stop itself is as soon as my x will become 0. So you can see one thing, what is my recursive work? My recursive work, okay, GCD, like find 6 modulo 4, right? So y modulo x, find y modulo x for me, and in the case of y, what will be returned is, what is my new y? New y is my old x, right? So I will return my old x, and my new x will be y modulo x. So this will be performed by recursion, but this will be called again and again and again. There should be a terminating condition, and we have seen the terminating condition is when y modulo x becomes 0. So when this x becomes 0, so as soon as if x is equals to 0, you will return, what you will return? You will return y. And but you should see one thing, that there is the return statement is inside if condition. There should be a return statement in each and every step, and this GCD should not be written alone here. It should be written like return GCD of y modulo x, x. So it will call again and again this function. Recursion will work, and at last when x equals to 0 will happen, it will return y, and at last here y will come, the answer will come, and this will be returned to our main function. Like this, the GCD will be calculated for 2 numbers only. So what can we do now? Now we should focus on how to find LCM of 2 numbers. You talk how to find, you have got that thing, that how to calculate GCD of 2 numbers, and the time complexity of this is logarithmic of minimum of x comma y. What is the minimum of x comma y? That is the logarithm. And in previously you are getting the minimum of x comma y, anything like that. This is a like this is a logarithmic function, and it will be much less than this one. So this is an efficient way to calculate the GCD, and this is called Euclidean method or something like that. So this way you can find the GCD of 2 numbers. Now how to find the LCM of 2 numbers? There is a very important formula to find the LCM of 2 numbers, and that is, suppose you are given 2 numbers x and y. X multiplied by y equals to LCM of x and y into GCD of x and y. So we have to do nothing to find the LCM of two numbers. We just need to get its GCD and divide it by. So if GCD comes this side, what you will get is LCM by GCD. So LCM will be x multiplied by y by GCD. That will be our LCM. So okay, now we know how to find LCM of two numbers, GCD of two numbers, and now you need to find LCM and GCD for a whole range, for a subarray. So how to do that? Suppose the limit is from L to H, from low to high. This is my subarray. How can I find the LCM and GCD for that whole thing? Is okay. So LCM means, I forgot to tell that LCM means lowest common multiple, right? Suppose 4 and 6 is here, and LCM means what number, there is what number that is divided by, completely divisible by both of these numbers. What is the maximum, what is the lowest common multiple? So 12 by 4, see, is 10 by 4 completely divisible? No. Is 10 by 6 completely divisible? No. So 10 can't be our answer. 11? No. 12? 12 by 4? 4 3 is 12. Yeah, completely divisible. 12 by 6? 6 2 is 12. Okay. So 12 is the LCM of 4 and 6. So this is the concept of LCM. This is the concept of LCM. It should be divisible by both the numbers completely, and there should be no remainder. And the lowest number that is divisible by, completely divisible by both the numbers, is called the LCM, lowest common multiple. So what we can find here next is, we can find the product. Finding the product is very easy. You can't assign product with 0, because multiplying anything with 0 will result in 0 and 0 and 1, 0. So as we used to initialize, for calculating the factorial, we used to initialize it with 1. Here for calculating the product, we will initialize with 1. So for I is equals to L to H, what we will do, product will be multiplied by nums of I. Okay, so like that, like this way you can easily find the product. And we have already made the GCD function of two numbers for finding two numbers. What you can do is, you can make a variable as GCD here, and this can take nums of low. LCM here, this can take nums of low as well. So you are assigning LCM and GCD with the first index of our subarray. After that, what you can do, how you will think of this is, okay, now what I can do is assign that LCM and GCD, and now I can store GCD of the GCD. Okay, suppose this is a variable, right? So make it GCD1. This is the function. I will pass GCD1 and nums of I. For the first time it will return nums of I as well, because these are two numbers. But for the next time onwards, and how will the LCM function work? LCM function will work by like, suppose we will make a LCM function, LCM of 1 comma nums of I. So here you can see, suppose we have got array like this, and this is the low and this is the high. First of all, we will calculate the GCD of this thing, and what the answer we will get. With the answer, we will calculate the GCD of this thing. What the answer we will get, we will calculate the GCD with this thing. What the answer we will get, the GCD with this thing, and what the answer we will get, we will calculate with this thing. And at last, like the same way, we will calculate the LCM as well for the first two. Then what answer we will got with the next one, then what answer we will got, and this way you can find the GCD of the whole subarray thing, right? So, but if you notice that this is a easy level question and the constraints are much less. The length of the array is at max 100, I think. So in cube will definitely work because 10 to the power 6 is lesser than 10 to the power 8. So now what we can do is we can have a for loop, and in that for loop will go from, suppose I equals to 0 to n. For the next for loop, like for taking all the sub arrays, all the possible sub arrays, you can have j equals to 0 to like I to n. And for the next time you will run another for loop from low to high. My low will be I, my high will be j. And after like for this one, you will find the product, you will find the GCD, you will find the LCM. And then what we'll do, you will check that the product is equals to GCD into LCM. If it is, then you have you can take a variable as total equals to 0. You can update your total that, yeah, I have found one such possible case. One such possible case I have found. So what you can do now, but look at the time complexity. The time complexity is in cube, right? And there is another possible, there is another like error can be detected here. The error is that the product maximum you can take as long variable, but the in the constant it is given that the number can be of maximum of 10 and the length can be of 100. So your product can max go up to 10 to the power 100, and you need to check for these edge cases also, because if there will be some test case that contains very rare edge case, then your code will not get submitted. And if you are in a contest, then it will give you a like penalty, or if you are in an interview, it gives a bad impression. So always discuss the edge case with the interviewer, or consider the edge cases. Think of all the weird or all the strange cases that can be there within the limit of the constraints. So we need to check that, we can put a check here that if the product is greater than the max value of long, then okay, no, we, so sorry, we know we don't need to find the total how many possible. We need to find the maximum subarray length. So you can put something as max length here, and if this condition is satisfied, then what you can do is max length is equals to math dot max. It returns the maximum value after comparing two values, right? So max length and high minus low plus 1, this is my subarray length, right? So what you can do now, but it is giving me, it is working with n cube. I can make it n square by a little optimization, and that is, you can check here one thing. The thing is that, just a little bit, yeah, so you can see one thing. What we do, we are first of all checking for this one, then this one, then this one, then this one. Like this way we are calculating, we are taking all the possibilities, right? So as we are starting from this, we are going first of all calculating this, then this, then this. So why we need a third loop? We can make two loops, and what we can do is we can assign the product here, GCD here, and LCM here, and we will find, first of all we will find the product for this two length. Then the product will be multiplied with the third one, and as the j is this one. First of all, the j is here. The product will be of this two, and the LCM will be of this two. Then, as the j increments, you will multiply it again with the j, and you will like find the GCD of the result of this two, and with this one. And as the j again increments, you will make the GCD with these two result and this one. And likewise, you don't need to make something as low and high. And now I will discuss the code in lead code, the code that I have written in Java.